Hello everyone. Today in this video we'll be discussing the ninth lab program of SS, which is regarding LRU and FIFO. Okay, so in that what we do is we have the page replacement algorithm. What do you mean by page replacement algorithm? We have a set of pages here. Okay, now what we have is just a finite size buffer is there. Okay, like cache memory is there. The first we'll be storing here, the next recently used, the next recently used, the next recently used, and a new page comes here. So at that time this any one of them should be overwritten, right? So which one of them will be overwritten, that is decided by the algorithm. Like in FIFO, the first which came in, that will be overwritten. In LRU, the least recently used will be overwritten. So those are the two algorithms which we'll be discussing. So first let's understand what is the answer in this case, and then we'll be moving on to the flow of the program, then finally code part. So let's fill this sheet given here. So by using FIFO, how can we do? First, if it is 1, then it will be just as 1. Then if 2 comes, then I'll be storing 1 2. If 3 comes, 1 2 3. And if 4 comes, I can store maximum 4 different things, so I can store 4 as well. Then if 5 comes, I have to replace something. So what I will do, I'll replace 5, means 1 I will replace, then I'll write 2 3 4 here as previous one. Then again 1 comes, so I have to replace the next first in first out order. So I'll have 5 1 3 4, and 3 is there, so 3 is a hit, so I'll mark it as hit. And after that I'll be just writing the same thing here, 5 1 3 4, and 1 is there, 1 is also a hit, so I'll marking it as hit, and I'll be writing the same thing, 5 1 3 4. And after that 6 is there, so 6 has to be replaced with the first in first out, so it will be 6 will be replaced here, and 4 will be here. Then 3, and 3 will be replaced here, 5 1 6 3, and 2 is here, so 2 is not present, so I have to replace 5 because that's the least means the first in first out order. 2 1 6 3, and 3 is there, so 3 is a hit. So out of 12, 9 were means page fault, and 3 were hit. So that's what we are trying to find out, how many page faults are there. 12 minus 3, which is 9. 9 is the number of page faults. That is the output for FIFO. Now let's understand what is LRU. Least recently used. In here what will happen is, here also the buffer size is 4. So 1 I will write, then 1 2, then 1 2 3, 1 2 3 4, and 5 is here. So which is the least recently used? The least recently used is 1 because it's staying from a long time, right? So I'll be replacing that. 5 2 3 4. Then 1 comes, 2 is the least recently used, so I'll be writing as 5 1 3 4. Now 3 is there, 3 is already present, so it is a hit. And 3 is the means most recently used. 1 again came. Now see, 1 again came, right? But we'll be comparing which one is the least recently used. 3 was used where? See here, 3 was used here itself. And what about 4? 4 is used from a means the greatest time. You just have to see, 5 is repeated here, 5 has been used at this point, 1 has been used at this point, 3 has been used at this means this point, at the same time 3 is there, and 4 has been used from not from so long, right? Means it has been used from a long time. So least recently used is 4, so I'll be replacing 4. So my answer will be 5 1. Sorry, 1 is already there, so it is a hit, so we will not make any changes there. And 1 will be the most recently used. And 6 is there, so what I have to replace is 4 because that's the least recently used. 5 1 3 6, and then again 3 came, so 3 is already present, so it is a hit. And 2 is there, 2 is not there, so which is the least recently used? If you observe here carefully, 5 has been there for a long time, right? So that will be replaced. 2 1 3 6, and 3 is already present, so it is a hit. So let's see how many hits were there. Here a hit was there, and here also a hit was there, and here one hit was there, here also one hit was there, right? So yeah, that's all. I guess the number of hits were there. So yeah, how many hits are there? 4 hits, right? It's a better one than the previous one, because in the previous one there were just 3 hits. Now here we have 4 hits. That means the more number of hits, the better the algorithm is. So it depends on the context and the input type as well, so we cannot like declare it as better one. So anyways, you got the concept right. Now let's move on to the code flow. Okay, in the flow of the program, first let me show you the code. This is the code. Okay, both for LRU and FIFO, it's just a switch case condition. So here we have the header files. Here we have some variables declared, and this is one function. Totally there are how many functions? 7 functions. Okay, along with the main function. So this one of the functions, get data. Then we have initialize. Then we have is hit. Then we have display pages. Then we have FIFO and LRU. This is FIFO and this is LRU. And then we have int main. Okay, so in int main, basically what's happening, just int choice is there, and you'll be just outputting which one you want to enter, and based on the choice you'll be calling that one. First get data if you want to get the data first, and after that FIFO and LRU are calling it. Okay, that's all what is there in the int main. So let's discuss the other functions flow as well. So here you have the header files stdio, and variables are declared as I showed in the second line. Some variables were declared. Totally 7 functions are there, and if you observe carefully, in the main function you are calling the 3 functions. Your choice 1 is get data, choice 2 is FIFO, choice 3 is LRU. So these 3 functions are called. Let's discuss what are the remaining functions. Initialize, is hit, and display pages. Okay, main function has only switch case which calls these, means the functions which are present here, FIFO, LRU, and get data. Okay, now let's see what is in get data. In get data, enter the length of the page sequence. You are entering 12. Enter the reference sequence, means if you are entering 12, what are the 12 numbers? What I mean is this one. How many numbers you are going to enter, and what are those numbers that you are storing in n. N is the variable, and in array. Okay, in array is used for storing the reference sequence. Number of frames are being stored in nf. Number of frames means how many at max you can have here, like 4. Okay, that you are storing in this one, get data means nf. So nf is 4, n is 2, n is 12, and in has a sequence of elements. That's what the get data does. After the get data we also have initialize. So let's discuss the code here, and let's see how is the flow. From the main function, first we will call the get data. So when we call get data, it will come here, it will get the data, it will ask enter the length of the page reference sequence. So we will be entering n value. Page reference sequence will be entering the numbers here in the in array, and will the number of frames, and if will be storing the number of frames. Okay, then what we are doing is we will be coming back here, and we'll be either calling FIFO or LRU. Let's go for FIFO first. So let's see what is in FIFO. So when you call FIFO here, it will call initialize first. So let's see what is the initialize function does. Initialize page fault count is equal to 0, and we are assigning p of I as 9999. Okay, p of I is nothing but the current frame. P of I is nothing but the current frame. So let's draw the arrays here for the FIFO. See, it is the 4 frames array. Okay, means the 4 frames, what is there, the cache. Okay, means this content is stored in p, this 2 content is stored in p, this 3 content, this 4 content, then this update is also happening in p. So p is just a cache for storing the buffer values. Initially it will be 9999, all will be 9999, and that's what the initialize function does. If you observe here carefully, in the FIFO we have the initialize function, then a for loop is there. It iterates through all pages, means 12, and I goes from 1 to n, which is from 0 to 12, which means 12 times it will iterate. Okay, and there's a for loop. For each page it will print the number of page faults. So for page 1 it will print some value, for page 2 it will print some value, and so on. Okay, so let's discuss that, what it actually is. So here what we have called the initialize function. That's done. Then we are coming here, the next line is int m is equal to 0. What does m do is it will store the if this is the array here, it will store the cache. Okay, means here it is stored the first in first out, like if it will be 1, then m will come here, then will be storing here 2, the next one m will come here, it will be 3, next it will come here, it will be 4, next it should not come here, it should come back here. That's why we are using m percentage n. Okay, so it will come back here, the next will be replaced here. Okay, like that it will happen in a cycle wise order, 1 2 3 4, then 5 6 7 8, like that it will keep on happening. Okay, so that's why the m is used. Then we have a function here which is running from means a for loop here which is running from 0 to n, and yeah, that's all what is in the FIFO. Okay, so that's the main thing here, we'll be discussing that, but that's all, and after that we'll be printing the page faults. Okay, so what is in the for loop, that's the main part. For the function for the number d, what is number d is the process. Okay, sorry, the page number. For the page number in of I will have all the page numbers. For that particular page number, what will be outputting is 2 if else conditions are there. Okay, is there a page fault, is there not a page fault? So how will we checking if there is a page fault or not? If it is not a hit, If it is a if it's not a hit means it's not present in the array. That means it's a page fault. If it's not a hit, it's a page fault. So we are calling is hit function and passing the data. So what does it is hit function do? Let's see that. Is hit function will be having hit as 0 and it will start from 0, j is equal to 0 to nf number of frames, so it will run from 0 1 2 3. So it's checking the basically it's checking the cache p. I told you p is the cache, and initially it is 999. I'm just starting here 9. So it will check as data. This is data what I have passed the first number, whatever is given to us, like it's the one right in the input. So that's the one is getting checked here. It's not, it's not, it's not, it's not. If it's not, hit will never become 1. Return hit, it will be written as 0, and then that will be compared. If hit is equal to 0, that means it's a page fault. If hit was 1, that means it was found. Hit was 0 only, that means it was not found, that means the page fault. If it's a page fault, what we have to do is p of m is equal to in of I. P of m is nothing but p of 0. In the cache I have to enter what? In of I. In of I is the input, so I will be entering in the input 1 and the rest will be 9999. Okay, and page fault count plus plus, since one page fault was done, page fault count plus plus, then we will call display pages. What does display page do? It will just display the content of p. If p is not 999, then display the value of p. That's what the function does. So what will be output for page 1? What is the input? Just 1. For page 2 it will be 1 2, and for page 3 it will be 1 2 3, and so on. Okay, now let's see what happens when there is a no page fault. When will there be a no page fault? If I already have the item in the p array. If I already have an item in the p array and my input is 1, I'll check it's present here, it will not be a hit. Okay, so if it's not a hit, it will just output no page fault, else it will output there is a page fault. That's all what is happening in the FIFO part. Okay, so to quick wrap up what's happening in the FIFO part, I have explained here. So see here, initialize thing is done, and for loop is running for all pages, and print the number of page faults at the last. What is in for loop is for page 1, for page 2, like that it will output, and what will be the output is either it will show the page status, which is like 1 to 4 or something, else it will output as no page fault. It is based on if else condition. If it is not a hit, if it is not a hit means it is equal to 0. Hit is equal to 0, that means it's not a hit. At that time what will happen, we'll store the input in the cache memory, we'll do m plus plus page fault plus plus and display the status. Else if it was found it was 1, at that time we'll print no page fault, means that was already present in the cache, we used it. Okay, it will be no page fault. That's what the FIFO part is. Okay, so here also I have mentioned the same, like what does display page do, what does is hit do, and these things already discussed here. So that was about the FIFO part. Let's discuss about the LRU part. LRU you have to listen carefully because there is an additional array which is the least array. Okay, so let's see what is in the LRU part. So comparatively LRU is a bit difficult than FIFO. So what's actually happening in LRU is initialize. First we will initialize the array. Okay, so let's do the initialization part. If you remember what happens in the initialization part, you'll be marking this as 9999, right? So I'm just writing here 9. Okay, not 999, 999. So it will keep on writing 999, and this is the content of p. That's what the initialization function does. And then we have list of 50. So our list array is created that we have made in the sketch part, and here we have the for loop. So when the for loop ends, at that time it will print the total number of page faults. Okay, so just a for loop is there, and here we have that for in I. So whatever the value is there in I, that will be printed first. So it will print as 1, and I have to print like is it a page fault or the sequence I have to print. Okay, so there are two options, like either it will be a hit or it will not be a hit. Okay, so you are checking if it's hit, if hit is equal to 0. What does hit is equal to 0 means? It's not a hit, right? So if it's not a hit, we will be doing this thing, else it will be no page fault. So let's see what happens if it is a not a hit, page fault. Then we'll be running j for loop here, j is equal to 0 to nf, and that will be running till here. Okay, after that is done, we are doing these things here. These things you are doing here. So let's understand carefully what's actually happening. J is equal to 0 till nf. Okay, so let's first fill the values. So this is what the initialization part is there, that is done. So let's see what is there in the code part. So j is running from 0 to nf, and nf is nothing but the number of frames. So the outer loop runs from 0 to n, which is 12, and the inner loop runs from 0 to nf, which is the number of frames. for each process we're checking the whole frame, like if that process is present in that frame or not. Okay, then int pg is equal to p of j. P of j, what it is initially, p of j is 9999, right? P of j is 9999, right? So page pg will be 9999. Okay, so let's write down that. So it will be 9999 pg. P of j means what? This value. This value will be stored in pg. Okay, after that has been done, what we are making the check is if this value is equal to, if this value is equal to this value or not. You remember, right? This is the cache. In cache, this is the first value. What we are checking is this value equal to this value or not? Okay, that's what we're making the next check here. Okay, so k is equal to I minus 1. I will be initially 0, so 0 minus 1, that will not run, so this for loop will not run here and will come here, and if not found, list of j is equal to minus 9999. So I'll be storing here minus 9999, and that will be happen for all the 4 process. Okay, so I'm just writing here minus 9. Okay, minus 9 minus 9 minus 9 minus 9. Okay, I've stored minus 9s in this place, so that's what the j loop will do. Because it's not found every time, it will not be found, so here I will be storing this as 9999. After that, min is 999, rep index. Again we are running the j loop and checking if list of j is less than minimum. Minimum is what? 9999. What is list of j? Minus 9999, right? It's obviously less than this one, so what will happen? Minimum is equal to list of j, so minimum will become minus 9999. Rep index is equal to j. Rep index means it's the 0th location, j is 0, so rep index will be 0. Next, what will happen? Minus 99 will be compared with minus 9999 here. Min is also minus 99. The next list of j value is also minus 9999, right? Why? Because all the list values are minus 9999, right? So it will be compared iteratively, but only this will be accessed because j will be accessed as this value. Then this will be compared as minus 9 is less than minus 9, that will be false, so j will not change, so j will be 0 only. And then what will happen when you come out of this loop? P of rep index is equal to in of I. What is rep index? 0. P of 0 will be in of I. What is in of I? What is I value? I value is 0, so in 0 will be in piece 0. So what is ins 0? So ins 0 is nothing but 1, that will be in piece 0 here, so this will come here and sit, so this will be 1 here. Like that, I'll just tell you orally what will happen next. See, if you observe carefully, and this is done, page fault count plus plus, then display pages. Then again I will be coming from 0 to 1. Okay, then it will become 2 and so on. So each time what will happen, I'll tell you orally. Now in the next iteration what will happen, right? This value is there, this value is there, right? This will become as 0. Okay, this will become as 0. From where it became 0? From here it will become 0. When you again go into the outer for loop here and come at this part, okay, this will not be a hit, so it will come here, and at this location p of pg is equal to in of k. Pj I have stored as 1 here, and the in of k is also 1 here. K will be equal to I minus 1, 1 minus 1, 0. So k is 0, in of k is in of 0. What is in of 0? In of 0 is the first input. First input is 1, and that will be compared with pg. Pg is also 1, right? So if both are 1, least of j will become k. What is least of j? Least of 0. Least of 0 will become what? K. K is what? 0. Least of 0 will become 0. So that's what I have done here. List of 0 is 0. Okay, that's what the change I have done here. List of 0 is 0. So that will happen in the this iteration. Next, what will happen? I'll make this change here. This will become 2, and this will become as 1. First, what will happen? It will check here, less than minimum, it will become 0. Not less than minimum, this minus 9 is less than 0, so this will also change. Like that it will become, next it will become 2. Okay, then it will become 3. In the next iteration it will become 3 here. Okay, then what will happen, at simultaneously I'll be storing the cache values also. the second and third input, which is 3 and 4. So 3 and 4 is stored. Now what will happen, this loop will run and it will get over. So when it gets over, what will happen, it will come back at this position. When it come back at this position, which is the least value here among 0 1 2 3, the minimum value is what, it is assigned as 9999. It will check 0 is less than 999. Yes, it is. So it will assign rep index as 0. It will check is 1 less than 0, 2 less than 0, 3 is less than 0. None of them is less than 0, so this will be taken into consideration. And at 0th location, the new element will be inserted, which is at first location, and that will be inserted as 5. The next input is 5, that will be inserted at this position. Then again 1 is there, right? I'll be searching, 1 is not there, so 1 will be inserted at this position. Then 3 is there, so it will not make any change. 1 is there, yeah, it's there, it will not make any change. Then 6 is there, yeah, 6 is not there, so it will make a change at this position, because that's most means least recently used. Then 3 is here, so 3 will be a hit, and 2 is here, that will also be a hit. Again 3 is there, it will be a hit. Okay, so that's what the changes is. And one more thing, it's least recently used, right? So if I encounter one after another one, it should get updated here. The updation does happen because 7 is here, right? So 7, what will happen, that will be stored at which location? Where was 1 initially? 1 was initially, I guess, here, right? So I'm not sure if 1 was here, the index value was 1, right? So 1 will just be replaced here as 7. Okay, so the least values will only be taken because that's the least recently used. What is the higher value, that is the more recently used, right? So that will not be considered. So only least recently used will be getting replaced, and that's how the and the printing will also happen at the same time. We are calling display pages. Each and this content will be getting displayed. Okay, so that's what basically in LRU is. It was a bit complicated, but that's what the working is. Now I'll tell you like how to remember this code. Okay, so for remembering the code, you need to follow the means the flow. You need to remember the flow. Okay, first you have what, header file. Okay, after that you have some variables here. Just remember 3 variables, which is the in array, n, and nf. Okay, then obviously p array we will get to know by the in array, because if in array is there, p array should also be there for storing the cache values. And here we have the n values, right? N for means n is the n variable has 12 and it has 12 values here, and nf is the number of frames, and the number of frames values are stored in p. Okay, then what we have is the 7 functions. What are the 7 functions? First, start from main. Here, the choice you will get, based on the choice you will either call get data, FIFO, or LRU. Okay, so in get data, what happens, you will be getting the data, you will be taking the number of pages, and for each page what is the value in array you will be taking, and the number of frames also you will be taking. That's in the get data. Then what you have is the two things, FIFO and LRU. In FIFO you will call the initialize function. So in initialize, just you are initializing the p array as 9999, and in display pages what you will do, you will just display the values which are not 9999. Okay, the rest of the values will be displayed. That's what happens in the initialize and the display pages. Is hit, what you will do, you will just check the p array. Here you will come to is hit, data is here, and you will check from j equal to 0 to nf number of frames, and you will check the p value for each the index value number of frames. If it's equal to data, hit is equal to 1, else it's hit is equal to 0, return hit. That's what the is hit function will do. Now in FIFO it's very simple. You will have an index m to keep the track of the buffer pointer, and then you will be checking for point means for each process you will be running, and then you'll be checking if it's a hit, if it's not a hit. If it's not a hit, means this for not a hit and this for a hit. Then no page fault if it's a hit. If it's not a hit, at that time you'll be inserting that new value in the cache, incrementing the cache pointer value. After that, page fault count plus plus and display the pages. That's all what is there in the FIFO part. The LRU parts also, it's simple. You'll be having an initialize function here. P is equal to 9999, least 50. You'll be creating for keeping track of the least recently used, and here you have the outer for loop running from 0 to n, and an inner for loop which is running from 0 to nf. Along with one inner for loop, again you have a for loop which is running from 0 to nf. This is for the setting of least value. This is for finding out which is the least recently used. Okay, that's for finding out which is the least recently used, and this for finding out if the cache value is present or not. So how you have to remember is, first you will be writing the outer for loop 0 to n, and after that you will be coming here and down and writing print total number of page faults. So what's happening in the for loop? In the for loop, what you have is print for the each process you will be printing, and you're checking if it's a hit or not. If it's a hit, you'll be doing the following code. Else if it's not a hit, at that time what you'll be doing, you'll be just outputting as no page fault. Okay, So let's see what if it's not a hit. If it's not a hit, you'll be running a j for loop, j loop, which is running from 0 to nf number of pages, and you'll be taking pg value, which is the least recently used, I mean the first cache value. First cache value will be taken, and that will be compared with the inputs. Okay, so I'm comparing the first cache value with the inputs. Okay, so what happens is, if I found it, I'll be making it found as 1 and inserting the in the least, that index will be inserted in the least value. Else if it's not found, least value will be minus 999. So this is just setting the least value. After setting the least value, based on what least value I've got, I'll be having a min value and finding out the least value in the whole array. So after I've set the least values, which is the most least value, I have to find out that. For that I'm finding out this one, and that index value is stored in rep index. So you'll be setting the rep index value in the p cache value, which is a minimum index value. In that what I have to store, the input k input value. The input value is the item which is found. Okay, so after that I am sitting here, and that's the least recently used, and then it will display the pages. So based on this, each time it will be the least recently used value set, and if it's already found, I'll again replace and change this index as the higher index value. So that's what is there in, so that's what is there in the whole code. And make sure you hit the like button and subscribe. Thank you so much for watching. I'll see you in the next one.